So in this video on names and addresses, I'm going to talk about the Dynamic Host Configuration Protocol, or DHCP, something which you probably use every day when you access the internet. So if we take a step back and think about what do we need to communicate with IP, with Internet Protocol, there are basically three things that a host needs. It needs first an IP address. It needs an address which you can give to other nodes to send packets to, and which you can put its own packets that nodes know to send back to it. It needs a subnet mask, so it needs to know what nodes are on its own local subnet versus nodes it must contact through a local gateway. It also needs to know the gateway router, such that if a node is not on the local subnet, what's the IP address of the next hop or the first hop towards destinations outside the local subnet. So these are the three things that you have to have in order to communicate with IP on the internet as a whole. In addition, often it's very useful to have this fourth thing, which is the IP address of a domain name service server, or domain name system server. This is basically which allows you to translate names like www.cnn.com into an IP address. And so you don't need this per se to communicate with IP if you just know the IP address, but it's very, very useful for most applications and for people. So there's this basic problem. You buy a new computer and you plug it into a network. You need these three things and hopefully this fourth one. How do you get them? How do you get these values? So in the old days, like actually when my first year in college, you'd get them from your system administrator. So you'd fill out a request for a network tap, and then a couple days later you'd get a slip of paper which had your important values. It had your IP address, it had your subnet mask, it had your gateway address, and it had the DNS server address. And so you get a slip of paper with these four things on it and a sheet of usually a photocopy saying, okay, take these values and here's how you open up your control panel and type them in here. And that was basically how you would configure your machine. So this is how I did it at Brown when I went there as an undergraduate in 1995. By the time I graduated, though, they had moved on. So if you imagine, on one hand, this can work, but there's all kinds of problems. If your machine moves, like if I take my machine and move it to a friend's room, it no longer works because that particular machine was configured for that particular tap in the network topology. So it's a question as to how long this lasts. So back then, when you got the slip of paper, it lasted a year. And in fact, if you didn't request it by a certain point in the year, you couldn't get one. So these addresses and configurations are given out on a yearly basis. One final question is, how do you collect unused entries? So if I only want a machine, plug in my machine for 3 days, does this mean that I have to allocate an entry for an entire year? The answer was yes. And so while this works, it's remarkably inefficient. So the approach that computers use today, and this is what Brown started using by the time I graduated across the entire campus, is something called DHCP, the Dynamic Host Configuration Protocol, specified in RFC 2131. Basic idea is that a machine, when it connects to a network, can request its configuration from a DHCP server. And if you can just request your configuration, say what's my IP address, what's my subnet mask, what's my gateway, what's my DNS server, this turns out to solve the three major problems I outlined. If you move, well, you just do a re-request. You're in a different part of the network, you need a different configuration. For the duration, how long it lasts, well, when the DHCP server gives you a configuration, it's associated with a lease saying the configuration is this good for this long. And then if you're nearing the end of that lease, you can re-request the same configuration, and usually the server will give it to you. So there's a way to renew the lease. These leases then make garbage collection very easy because if somebody doesn't re-request it, you can reclaim, say, that IP address. And so the basic interaction, the basic packet exchange that you see in DHCP is there's a basic four-step exchange, and then there's this optional release. So when a node first joins the network and it knows nothing about what's going on, it sends out a discover message. I want to discover what DHCP servers are out there and what configurations they might give you. So the client sends a discover. Then the DHCP servers that can hear that discover respond with an offer. So here are the servers. And more than one server can be connected, and you might get more than one offer. And it'll say, here, I'm going to offer you this configuration. The client then selects one of the configurations and sends a request to the originating DHCP server saying, well, I'd like to request that configuration you offered me. And then the server sends an acknowledgement saying, I acknowledge you can have that configuration. This configuration is now valid for the duration of its lease. And a client can release it early if it wants to, or if the lease starts to reach the end, it does a re-request. So the request mechanism is both in response to an offer, but also a way to renew a lease. So let's walk through an example with a client and two servers. First up, a client connects to the network and it sends a DHCP discover message as a broadcast. Server A and server B both hear this message. There happen to be two DHCP servers that can hear the discover broadcast. And let's say both respond with offers for different configurations. So here's an offer, offer B, and offer A. The client, seeing these two offers, decides that it wants offer B, and so it then sends a request to B saying, I would like to request the configuration that you offered me. Server B can then acknowledge and say, okay, you have it. Server A doesn't hear a request for the offer, and so at some point then that offer will time out. Now client A is configured. It has an IP address, it has all it needs to communicate. If the lease on this offer gets close to an end, it can re-request and say receive an acknowledgement, and it'll do this well before the lease expires. So now the lease has been extended, and then it can also optionally send what's called a release and say, oh, actually I'm done with this. In practice, clients often don't do this, they just let the lease expire, but sometimes you see it on your control panel, you can say release, and I'll show you this in an example on a Mac in a second. So here would be a basic DHCP sequence, or exchange of messages. So I've said you send these messages. What do these messages look like? The issue here is you're trying to bootstrap IP. You're trying to get the beginning IP configuration before you have any IP information. And so the way it works is a client sends UDP packets to port 67, that's the DHCP port, from port 68. And it sends these packets. It doesn't know the IP address of the DHCP server, so it sends them to the broadcast IP address and also makes them come from the broadcast IP address since it doesn't have an IP address. In cases where the DHCP server is not on the exact same link, you can have relays that will forward it across links. And most switches, etc., will actually just forward broadcast packets across all of their ports. And so the way you bootstrap this is to use the special IP address, communicate using UDP packets, then once a node has received its configuration, it now can bootstrap with its own IP address. And so this is then the message exchange that we see. So you start with my iMac issuing a DHCP discover. It sends this. So here's my source Ethernet address, 0454531078E4. And it sends it to the Ethernet broadcast address, so all ones. The source address is 0.0.0, the source IP address. The destination IP address is 255.255.255.255. And you can see it's sending it from source port UDP port 868 to destination port 67. And if you look inside this message, right, this is basically just the basic DHCP discover message. It sends it once, doesn't hear anything, so it retries after a second, doesn't hear anything, so it retries after another 2.5 seconds. Then it hears two offers, which perhaps might be a response to these two different discovers, who knows. Since they have the same transaction ID. So this first offer is sent from 1033.0.2 to IP address 1033.1.94. The second one is 1033.3.188. But if you look inside the Ethernet frame, these are being sent from some device, and they're being sent to my Ethernet address. So these are offers that are sent in response to my discovery. And you can also tell by the transaction ID. And so this is destined to this IP address. Because my node knows that it doesn't yet have an IP address, this turns to be part of, in fact, the information. And so here's the reply, the offer. and there's all this configuration information. It's basically saying here, I'm offering you an IP address of 1033.19.94, which maps up here, 10.33.1.94. And the same in the second one, you'd see that it was offering for 10.33.3.188. So you've got two different IP addresses you might want. Turns out there are all kinds of options in this message. It's also going to tell me the subnet mask, 255.255.48.0. It's also going to tell me the router, 10.33.0.1. And it's also going to tell me the domain name server. It's going to tell me that my domain name servers, here are 3 servers that I can use, 171.64.755, 121, and 99. It's also going to tell me a domain name. Oh, you're in stanford.edu. And so that's what these offers contain, all this information which I can use to configure my host when it starts up. Then, in response to one of these offers, my device sends a DHCP request. Right? And so now it's sending, again, here's from my address, sending as a broadcast, it broadcasts its request. And if we look, which IP address did it choose? Right, so here's all this information, all these flags, options. So, parameter request list. So I'm requesting a certain subnet mask, router, a certain subnet mask, a certain router, domain name server, etc., etc. And so we can see here that my node ended up requesting the first offer, so 10.33.1.94. And it also ended up requesting a host name, Philips iMac. So it's saying, hey, I would like to respond to the request. I would like to request the offer that you made for 10.33.1.94. Then the DHCP server acknowledges that and all as well. And so now if we open up my network control panel, and we look at what my configuration is, that's in fact what we see. So my IP address is 10.33.1.94. My subnet mask is 255.255.248.0. My router is 10.33.0.1. And if we were to check, my host name would be philipsimac.stanford.edu.